Okay, let's talk about measuring the density of a regularly shaped object. And what I have is a cube of cork. And first thing we'll do is we're going to put that cube of cork on the balance. We're going to close the door and we're going to record that mass. The mass is 0.337 grams. So now since we have the mass, we can need to get the volume if we want the density. And so since it's a cube, all the sides are the same length. And so that's just above 1, but not quite 1.1. So we're going to call that 1.08 centimeters. And since each of the sides are the same, you essentially have a 1 centimeter cube. And so you use length times width times height to get the volume. And we have the mass, so then you can calculate the density. So now we want to determine the density of an irregularly shaped object. In our case, what we have is some metal shot. So to do that, we need the mass of the metal shot. So we're going to put our weighing boat on there, and since I'm going to be right here measuring the whole time, I'm going to tare it. Sometimes you'd record the mass and then subtract. You can really do it either way. I'm just going to tare in this case, and that's going to take the mass into account. Close the door, try that one more time. Okay, so then we're going to add metal shot to it. And so we're going to put that metal shot into the weighing boat and close the door. So now, if we zoom in, we see we got 13.492 grams of our metal shot. Since the volume of the shot is irregular, I can't really use a geometry formula to get its volume. So one way of doing that is volume by displacement. In this case, we have some water. We record its initial volume here. It looks to be just under 30 milliliters. We'll call that 29.7 milliliters. And then what we do is we add the shot to the water and then measure how much the volume increases. The change in the volume is the volume of the shot. So we're going to add the shot that we weighed before to the water. And so that's all the shot. But what we can notice is that we're not at 30 anymore. It has gone up. We're not quite to 40. So what we need to do is look at our lines and interpret. So there's 31, 32, 33, 34. And we're kind of close to pretty much right on 35. Maybe just ever so slightly less if you look at the bottom of the meniscus. And so we'll call that 34.9 milliliters. So we have the mass, and now we've determined the volume, or we can determine the volume by the displacement of the water, so you should have everything you need to be able to calculate the density.